Hi everyone, this is Miss Graham, and today we are going to be looking at Lesson 8, Surface Area and Volume of a Sphere. So we are going to pull out pages 19 and 20 in our Surface Area and Volume packets. Now, so far we have covered both the surface area and volume of 4 other shapes. We've looked at prisms, pyramids, cones, and cylinders. So now what we're going to do today is we're going to focus specifically on spheres, and we're going to look at the surface area and the volume. For our other shapes, we kind of broke it up into surface area in one section and volume in another, so that way we could look at the lateral area as well as the total surface area. But for spheres, we really just have our total surface area versus the volume. So let's go ahead and get started by looking at our definitions of a sphere, as well as some vocab that goes along with it. So we can start off with looking at a sphere and writing down that it is a round, solid figure with every point on its surface is an equidistant from its center. So let's start off writing, it is a round, solid figure with every point on its surface equidistant from its center. So we can see we have our visual right here, that's our sphere. Now our radius is actually going to be marked kind of in pink. So our radius, it connects essentially our center point to a point on the sphere. So we're going to write that down for our radius. It connects a center to a point on the sphere. We can also label that with a letter R. Now for our diameter, we know our diameter is essentially 2 radiuses or 2 radii put together. I drew a separate line just so we could see it straight across, but we know it connects 2 points on our sphere and it also goes through the center. So let's go ahead and write that down, that it connects 2 points on the sphere that is through the center. Now, those are the different vocab words that we'll see within a sphere, but what about a hemisphere, right? It's part of a sphere. It's actually going to be half of one, exactly half of it. So if we cut this directly kind of in half here, we could take the top or bottom, and that is a hemisphere. Now, we're going to probably go into a new vocab word that you haven't seen yet, a great circle. So that is a circle that has the same center and radius as the sphere, and it divides a sphere into 2 hemispheres. So that's essentially what we're looking at right here. That's going to be our great circle. So let's fill it in. So it is our circle that has same center and radius as the sphere, and it divides the sphere into 2 hemispheres. So that's going to be our great circle. So now that we better understand this vocabulary, what we can do is we can start to look at the sphere formulas, both for surface area and volume. So keep in mind, in our past couple of shapes, we looked at lateral surface area as well as total surface area. Well, here for a sphere, there's really only total surface area. That's all we're going to be working with here, because there's no way just to have the lateral piece. So the area formula for that will be 4 times pi times r squared. So if we know the radius of our circle, we can find its surface area. Now, looking at the volume, so how much it holds inside, well, that's going to be a little different. We're going to write that as our volume equals, it will be 4/3 times pi times r cubed. So we can see for both formulas, if we have the radius, we're able to figure out the total surface area as well as that volume. So that's pretty helpful for us. So now we're going to go ahead and apply these 2 formulas in a couple of example problems below. So let's look at number 1. It says find the surface area and the volume of the sphere below. Leave your answer in terms of pi. So I can see, and I already started to label this, that my diameter is going to be 8 meters. So what does that mean? Well, that means my radius will be 4 meters. So look at that. I can write down the formulas that I had for total surface area as well as for volume, and I can just plug in my radius. So for total surface area, it'll be 4 times pi times 4 squared. So 4 squared is going to be 16. 16 times 4 is 64. And since we're leaving this answer in terms of pi, it will be 64 pi. And since we're looking at total surface area, we will measure that in 2-dimensional, so it will be meters squared. Now looking at volume, we can plug in a radius of 4. So we'll have 4/3 times pi times 4 cubed. 4 cubed is 64. Now when we multiply 64 times 4, we get 256. We're still dividing by 3, but what we find out is we can't divide 256 by 3 evenly. So we just keep it as is, and we're multiplying it times pi. So our answer will be 256/3 pi. And remember, this is 3-dimensional since we're looking at volume, so it'll be meters cubed. All right. I'm actually going to have you now try example 2 on your own. So go ahead and pause the video, play it when you're ready, and we can go over the answers. All right, let's go ahead and go over example 2. So if we're given a diameter of 10, that means our radius is 5. So our total surface area when we plug in 5 as r should be 100 pi feet squared. And for our volume, when we plug in a radius of 5, we should end up getting 500 divided by 3 pi, and that is going to be feet cubed. So example 2 is very similar to example 1. Now let's kind of look at a real life story problem incorporating circles. Maybe the surface area, maybe the volume, maybe only one or both of them. So let's go ahead and look at example 3, the last one on page 19. So it says the Earth's equator is about, 24,902 miles long. Dang, that's pretty long. So it wants us to approximate the surface area of the Earth. Wait a minute. So we know we're going to be looking at the total surface area formula, but right now we're not given the radius, are we? Maybe we are. I don't know. Let's look back at this. The Earth's equator is this long. So I will tell you that equator is going straight through the center. That's how we're going to look at it in this problem. So essentially, that number represents our diameter. So if we want our radius to approximate that total surface area, we got to take half of that. So I'll do the math for you. We end up with our radius as 12,451. So that's what we're going to plug in our formula for the surface area. So let's go ahead. We're going to square that radius, multiply times 4, and again, let's leave our answer in terms of pi. And we're going to realize we get a really big number when we put this in our calculator. We end up with 109,604 times pi. And since we're looking at miles and we're looking at area, it will be in miles squared. Whoa, so that's kind of crazy to look at the surface area of our Earth. I mean, that's insane. We could even multiply this number times pi, and it'll be a little bit more than 3 times that amount, since pi is around 3.14. So we got through our first page. We're definitely going to go and practice some more of these problems, not just looking at surface area, but also looking at volume. So let's go ahead and head to the next page, page 20, which is actually the last page in the surface area and volume packet. All right, we are on our last page. So example 3 just focused on surface area. So now for example number 4, we're just going to focus on volume. So it asks us to find the volume of the sphere below. And again, leave your answer in terms of pi. So keep in mind, it actually gives us the radius this time. So we can label 6 meters as r. Now our formula is volume equals 4/3 times pi times r cubed. So we can plug in 6 into r spot. So I have 4/3 times pi times 6 cubed. When I figure out 6 cubed, multiply it by 4, and divide it by 3, I actually do get a whole number. And since we're leaving this in terms of pi, we're going to take that number, which ends up being 288, and multiply it times pi. So we have 288 pi, and since we're looking at volume, it is meters cubed. Now, keep in mind, even though we are using these formulas, we might not always be finding what the volume is or what the surface area is. We might be asked to find possibly what the radius is or the diameter. So that's going to require a little bit of algebra skills from us and a little bit of manipulation. And that's a little bit of a preview of what we're going to see in number 5. So number 5 asks for finding the diameter of a sphere with a volume of 972 pi inches cubed. Well, since we're working with volume, let's just start off by writing down the volume formula. So volume equals 4/3 pi r cubed. And maybe what we can do is we can plug in what we know. So we know the volume is 972 pi, right? So we could plug that in. And we are essentially going to find our radius cubed. So let me plug that in for a second. Now what's really cool here is if you look at this problem, is we have pi on both sides. So you can already see I can actually cancel it out because if I divided pi on both sides, it would actually cancel out. It'd end up being times 1. Now the next piece I'm probably going to figure out, since I want to get r by itself, is to figure out how to get rid of this 4/3. Now you could do this in 2 steps. You could think about how you can multiply by 3 to both sides and then divide by 4. But we know that timesing by 4/3, that's actually the same as multiplying by 3/4, that reciprocal. So that's actually what I'm going to do for both sides. So that's why I kind of put these parentheses around right here. So what happens? What do we get? We actually get 729 equals r cubed. And in order to get r by itself, we actually take this cubed root of both of those. So keep in mind, there's a lot of work, there's a lot of manipulation to here to what happens. So we end up getting r as 9 when I take the cube root of 729. And keep in mind, if you need to use your graphing calculator to figure out the cubed root, remember you can always go to the math button to help you figure it out, cubed roots. Now, we want the diameter, so we're going to take 2 times the amount of 9, so that way our diameter will be 18, and since we're looking at inches cubed for volume, our label here for diameter, since it's one-dimensional, will just be inches. So look at that. We were able to take our original equation, manipulate it to solve for one of the other variables. And we're still able to apply this idea of finding a piece of our circle, our sphere. So looking at number 6, we're actually going to step it up a little bit. You're probably thinking number 5 was a little bit of a step up. It is, but 6 definitely starts to work up to it. And if some of you can see when we get to number 7, whew, that is a little bit of a tough problem too. So let's start off looking at number 6. It wants us to find the volume and surface area of this hemisphere below. So keep in mind, we're really taking half. We're going to take half of what we're looking for, right? If we want to find the volume, we're going to take half of the amount because it's split in half. But for surface area, it's a little different. We are going to take half of the total surface area. But keep in mind, we want this pink part on top too. That's the area of our great circle. So that vocabulary word makes a little bit more sense now. So we'll have to add half the area of what we get for our sphere along with the great circle. So it is a little bit easier to find volume since we're just taking half of what it would be for the whole sphere. So let's go ahead and write that down for starters. So for our volume, right, we can write down 4/3 times pi times r cubed, but then I'm going to multiply this by a half because I want half of it. Again, you could wait until the end and just divide your answer by 2, but for me, it's going to be a little bit easier to kind of condense these fractions. So I know since I'm multiplying everything, I could rewrite 1/2 times 4/3. I could multiply across and rewrite it as 4/6. So I'm going to go ahead and I'm going to do that. I'm going to rewrite it as 4/6 times pi times r cubed. Now, in our problem, they actually give us that radius, so we can fill that on in. Our radius is 11, so that's why I filled in 11 cubed. Now doing the math of 11 cubed, multiplying by 4, dividing by 6. We don't get really a whole number. We do get a fraction, but I'm going to reduce my fraction as small as possible. Now, if you're working through and you have your fraction, keep in mind, you could always go to, on your calculator, if you have a decimal, you could go to the math button and take that decimal and change it into a fraction. There's a button that's called frac, F-R-A-C. So even if this is a decimal, again, keep it in terms of pi. Even if this is a decimal, you can figure out what that fraction is. Actually, the calculator figures it out for you. So that simplified fraction will actually be 2,662 over 3, and that will be times pi. And since it's volume, we are looking at inches cubed. So now, total surface area. Remember, there's 2 parts. It's half of the surface area from before, as well as the area of this great circle. So I'm going to write down that formula as our total surface area will equal half of the sphere's area. Remember, because it's a hemisphere. So the sphere's area is 4 pi r squared. And then we're going to take half of that. And then I'm going to add the great circle. So what I put in pink over here, I'm highlighting in pink here. So remember, we'll talk about what that area is, but let's start off making this a little bit simpler. 4 times a half, I could actually rewrite that as just 2. So I have 2 times pi times r squared, which I know r is 11. Now, for our great circle, that area formula, right, for just a general circle is pi r squared. So think back to what we learned maybe a couple of months ago about that, and we're going to fill in what we know. So we know that radius is 11, so I have pi times 11 squared. And I'm going to add it to, well, 11 squared times 2 times pi. That result ends up being 242 pi. So I'm essentially, and I can kind of tell you, 11 squared is 121, so I'm adding 242 pi plus 121 pi. When I do that, I get 363 pi, and since it's total surface area, it is inches squared. So we are going to come back to number 7, but I figured let's end on that problem since it's probably the toughest of them. So let's go ahead to number 8, and I'm actually going to have you do a little practice on this problem. So let's go ahead and just read the problem first. Giant squids need large eyes to see their prey in low light. The eyeball of a giant squid is approximately a sphere with a diameter of 25 centimeters, which is bigger than a soccer ball. Whoa, I don't want to run into a giant squid. A human eyeball is approximately a sphere with a diameter of 2.5 centimeters. Oh my. So how many times as great is the volume of the giant squid's eyeball as the volume of the human eyeball? So here, what you're going to have to do is you're going to have to find the volume of the human eyeball, the volume of the giant squid eyeball, and we're going to have to compare them to see how many times bigger it is. So I at least want you to start off and figure out what the 2 volumes are. Once you do that, go ahead and press play so we can go over the answers. All right, so let's check to see what we got. Again, looking at this, I'm actually going to leave my answer in terms of pi, and I know you're probably getting a decimal. You're probably like, oh my gosh, this decimal is a little bit crazy, but you can see there's kind of a pattern with the results we get. So for me, the volume of the human eyeball, I gave quite a few decimal places after. I tried to follow kind of the same number pattern as with the giant squid eyeball too, kind of stopping on the same 7 after going through a series of 4 6s. So for the volume of the human eyeball, I got 2.604166667 pi. And the volume of the giant squid, I got 2,604.166667 pi. So now, in order to figure out how much bigger it is, what I'm going to do is I'm going to take my giant squid eyeball and divide it by the human eyeball to figure out how many times bigger it is. So that's something we can actually put in our calculator. Now, keep in mind, if I'm having pi over pi, that cancels out. So I essentially just have to put these numbers in my calculator. So I'm going to go ahead and give you an opportunity right now. Pause the video, try putting these in your calculator, and see what you get. All right, hopefully when you put them in your calculator, you got the number 1,000. So we can see that our giant squid's eyeball is 1,000 times bigger than the human eyeball. Its volume is. Whoa, that's kind of crazy. It makes you sometimes think, oh my goodness, giant squid is a little bit intimidating if that's just its eyeball. All right, you ready for our tough problem? Our number 7. Yeah, I am ready for it too. It's the last one that we're going to end on for this packet. So let's get excited. So let's read the problem. It says the volume of a sphere is 5,000 meters cubed. What is the surface area of the sphere? Ooh, this is a little tricky because we really don't have one common equation we can use. It gives us information for the volume, but it wants us to find the surface area. Basically, if we compare those two formulas, the thing that's in common is our radius. So maybe what we have to do is we have to take our volume formula and maybe we have to solve for r. So for me, I can plug in 5,000 for that volume, and I have that equals 4/3 times pi times r cubed. Now again, kind of from our previous problem, if we look back on number 5, we have to solve for r. So really the best thing to do here, since pi is not on both sides, is really to get rid of this 4/3. So we could do this in 2 steps. I'm going to do it in 1 step because I know multiplying by 4/3 is the same, the opposite operation of multiplying by 3/4. So I'm going to multiply both sides. I'm going to put parentheses around this and multiply both sides by 3/4 to cancel that out. So I take 5,000, multiply it by 3, divide it by 4. I actually get a whole number. I get 3,750. So that equals pi r cubed. And then this is kind of the tricky part. We are going to divide by pi. It's actually not going to cancel out. So we're going to have 3,750 divided by pi. Now I'm running out of a little bit of room, so I'm going to start to kind of creep up over here. So I really have 3,750 divided by pi, and that's going to equal r cubed. Now the next thing I can do to get r by itself is take the cube root of both sides. So that way I'm just left with r on the right. Now, this is a little tricky, right? We're taking the cubed root of 3,750 divided by pi. So to kind of help us out, right? We know we're going to get a decimal approximation, but you know me, I don't like to round mid-problem. I like to try have as an exact answer as possible. So essentially, this is what's going to equal our radius. I'm going to actually keep this as it is for right now and replace this into our surface area equation. Because essentially our surface area, right, is just plugging in what our radius is and solving. So let's write down our formula for a total surface area again. It's 4 pi times r squared. So I'm going to go ahead and plug in what I got as my radius. So I have 4 times pi times the cubed root of 3,750 divided by pi, and then that's going to be squared. Now, I will tell you, this is a little hard to put in your calculator. So I actually kind of made a little bit of a note for you on how you can put it in your calculator. So be careful when you put in the calculator. And here's what I'm going to have you start off doing. So go ahead and pull out your calculator. All right. So here's what we're going to start off with. We're going to type in 4, and then I'm going to use the pi symbol. So find your pi symbol on your calculator, type that on in. Then we're going to put a set of parentheses twice. It's really going to represent what we're looking at. And I'll talk about this soon, why I'm putting so many parentheses. But then I want you to type in 3. Actually, sorry, not 3. I forgot about this. We want the cubed root. So scratch that 3. Scratch that 3 for a second. Don't type in 3. What I want you to do is I want you to go to the math button, and I want you to find the cubed root button. And that's what we're plugging in. We're taking the cubed root. So it'll look like that, where the 3 is really the index inside of our root sign. We're going to come up with another parentheses that will pop up when you do cubed root. Then we're going to type in 3,750. We're going to click the divided by sign. And then you're going to type in pi. And you're going to close that parenthesis twice. You're then going to hit the squared button and then close the parenthesis. Whoa, so let's actually start talking about what this actually means. So I first started off making sure that right here, I had that fraction all underneath the cubed root sign. So that's what these set of parentheses were first for. Then I wanted to make sure I had this whole piece. When I took the cube root of it, I wanted to make sure the whole thing was squared. So that's why I put the parentheses right there. Then last but not least, I wanted to make sure this whole result here was multiplied, right, by 4 pi. So what I did was I then put the last set of parentheses there. So essentially what I kind of had to do is I had to kind of write it out first and then type it in my calculator. So if you did type it in correctly, we should actually all get the same result for a decimal. So let's round to, I don't know, let's say 2 decimal places. When we click enter, we should end up getting 1,414.05. And since it's total surface area, it will be meters squared. Wow, was that a complicated problem? Yeah, it was, but it was good practice using our calculator and typing that on in. So look at this, we are done with our notes. So keep in mind that we are going to start reviewing for our fluency check. We're going to start over the next couple of days next week, and then we're going to have our fluency check 18 next week. So have a good rest of the day and happy mathing.